Woohoo! Welcome back. Today, I hope you're ready for something fun because we are going to rock it with Mars. We're going to throw rocks on Mars. Yay! And in order to do this, we're going to be using both average velocity and instantaneous velocity. So, if a rock is thrown upward on the planet Mars, and again, this is going to be a very simple model, so it's from the surface, weirdly enough, so like a stomp rocket kind of thing. With a velocity of 10 meters per second, its height in meters after t seconds is given by h equals 10t minus 1.86 t squared. Now remember, we're used to seeing a different number here for the acceleration due to gravity, but this is because this is on Mars, it's a much smaller number. Okay, find the velocity of the rock after 1 second. Technically, we can't. There's no way for us to do this right now back in 2.7. As soon as we get up to 3.1, easy peasy, and even 2.8. So, but right now, we're not going to be able to do this exactly. So we won't be able to find the instantaneous velocity, but we will be able to find the average velocity. So this is what we're going to do. Pardon me. So we're going to look at what happens from t equals 0 to t equals 1. And this is in seconds. So at t equals 0, our height is 10 times 0 minus 1.86 times 0 squared. Well, that's just going to give us a big old goose egg there. So the height is 0. So that makes sense. Right before we shoot this rock off of the planet with our little stomp rocket, we're going to have that the rock is on the ground. So that makes sense. When time equals 1 second, the height is going to be 10 times 1 minus 1.86 times 1 squared. That's going to be 10 minus 1.86 because 1 squared is 1. And then that's going to give us 8.14. And that's in meters. And I should have written in 0 meters. And so we know what's happening at time equals 0. We know what's happening at time equals 1. And so what we can do is we can look at the average velocity. So the average velocity is going to be equal to, we're going to look at h. Here, let me go ahead and write out the formula so it's very clear. The height at the second time minus the height at the first time over the time. So how far did it go over how long did it take? So that's our formula for average velocity. This is going to be 8.14 meters minus 0 meters. Oh, I didn't need to include the meters. Oh, that was exciting. Sorry, for a second there, I forgot I was a mathematician. So we don't include the units when we actually do the calculation. Sorry about that. So 8.14 minus 0 all over 1 minus 0. So it's going to be 8.14 all over 1. And this is, remember, this is going to be meters over seconds. So it's meters per second. So the average velocity is 8.14 meters per second. So we can make a lot of guesses about what's going on. It is actually thrown or shot upwards at 10 meters per second. So it has obviously lost a little bit of speed. But we don't know from just doing this, we don't know whether we're on this side of the upward curve to the point where obviously we're not here at the top because that would be at 0. So the velocity would be 0 up here. So we're down here somewhere, or maybe we've already come back down and we're over here somewhere. We're not sure. So average velocity gives us a number, but it doesn't give us a lot of precision about what's happening exactly. But it does give us an idea of what's happening after 1 second. So the next question we're going to ask is find the velocity of the rock when t equals a. So rather than specifying the 1 second that we did up above, we're going to pick just a variable And that way we can just get a formula and plug in whatever time we want. So we're going to do the same thing when t equals 0 seconds, the height is 0. When time equals a seconds, the height is going to be, and we've got our formula up here. So I'm going to use the same formula we had up there. I just don't have enough room to, I have to keep shifting this up and down. This is going to be 10t minus 1.86 t squared. So at a seconds, this will be 10a minus 1.86 a squared. Okay, so we just plug that in. And so then we can use this, again, if we want the average velocity, the second height minus the first height all over the second time minus the first time. And remember, you can do h1 minus h2 if you want. You could do this in either order as long as these two agree. So h2 has to be above t2, h1 has to be above t1, but if you want, you could switch the order. Oh my goodness, I did not leave myself enough space, but I've got 10a minus 1.86 a squared, and since we're comparing it to 0, it makes that part pretty easy. And then this is going to be over a compared to time 0. So that's going to be 10a minus 1.86 a squared all over a. See how exciting? I told you. This was going to be the most exciting ever. And then I'm going to realize, wait a minute, I want to cancel. So in order to cancel safely, remember we want safe cancel because it's easy to make mistakes with canceling. I'm going to factor out whatever I'm going to try to cancel. So I want to cancel an a, so I got to factor out an a. Now, is it possible I could factor out more than a? Sure. You could probably cancel some other things. We could get creative. But since I'm only going to cancel the a, that's all I'm going to try to factor out. So if I factor out the a, 10a becomes just 10. 1.86 a squared becomes 1.86 a. And then, can you guys see this? Yeah, just barely. I can cancel the a's. And then I get 10 minus 1.86a. And this, and let's see if I can fill in, this is the average velocity, let's spell it in the right order, from or between t equals 0 and t equals a. So now we got a formula. And we could double check this formula because if I plug in up here, right, I wanted to do the time was 1 second. So I could plug that in here. And if I plug in 1, I get 10 minus 1.86 times 1. That's 10 minus 1.86. And that does, in fact, give us the 8.14. So life is good. Woohoo! And of course, I can write meters per second here. Put a little box around it. Make it so fancy. Woohoo. Okay, in the next video, I know you're all thinking, wait, there's another video? There is another video. There might be 2 more videos. I mean, there's just a potpourri of videos, actually. So in the next video, we're going to go from average velocity, and we're going to talk about how do we approach more the concept of instantaneous velocity. I know, it's pretty exciting. So get yourself something nice and warm to drink. That's my warm drink right there. And or cool if it's hot outside right now. And come back and we'll do another video, instantaneous velocity. I know, very exciting. And until then, you know, be really gentle with yourself because this stuff is not easy. And take care, be gentle, woohoo, and math on. Woohoo, yay.